OCR Revision Guide, page 87, Electron Transport Chain. They're found in the mitochondria, of the inner membrane to be precise. The inner membrane has a different lipid composition from the outer membrane and is impermeable to most small ions, including hydrogen ions or protons. It's folded into many cristae, which gives it a large surface area, and it has embedded in it many electron carriers and ATP synthase enzymes. Those carriers are protein complexes, and they're arranged in what we know as the protein transport chain. Each carrier is an enzyme, and it's associated with a cofactor. The cofactors in this case are non-protein groups. They are heme groups and contain an iron atom. The cofactors can accept and donate electrons because the iron atoms can become reduced to Fe2+ by accepting an electron and being oxidized to Fe3+ by donating the electron to the next electron carrier. They are oxidoreductase enzymes. This means that they're involved in oxidation and reduction reactions. Pretty obvious, really. Some of the electron carriers also have a coenzyme that pumps proteins from the matrix to the intermembrane space, using energy released from the passage of electrons. Because the inner membrane is impermeable to small ions, proteins accumulate in the intermembrane space, building up a proton gradient, a source of potential energy. The ATP synthase enzymes are large and protrude from the inner membrane to the matrix. They are known as Stork particles, and they allow proteins to pass through them. Not proteins. Protons flow down a proton gradient through the ATP synthase enzymes from the intermembrane space into the matrix. This flow is called chemiosmosis. The force of this flow, the proton motive force, drives the rotation of part of the enzyme and allows ADP and P, inorganic phosphates, to be joined to make ATP. The coenzyme FAD, which becomes reduced during one stage of Krebs cycle, is tightly bound to a dehydrogenase enzyme that is embedded in the inner membrane. The hydrogen atoms accepted by FAD do not get put into the intermembrane space. Instead, they pass back into the mitochondrial matrix. FAD is flavine adenylene dinucleotide, derived from vitamin B2 or riboflavin, adenine, ribose, and 2 phosphate groups. The end.